Today we're gonna see first of all, good morning to all of you. Today we're gonna see another problem that is solved by DP approach. And DP is a dynamic programming, right? As we have earlier seen, we have studied the characteristics, we have studied the recursive function, we have studied the elements of DP, and then we have studied a Floyd virtual algorithm. That is all pure shortest algorithm. So let's see how does it work. We have already seen that DB, that what are the correct, how to characterize the structure, how to recursively define, because in the DB, each and every problem is having the recursive formula as we have seen. And then we have to compute the value for the lower substructure, then we have to compute it recursively for the higher order, right? So that we can get the final optimal solution. So let's see. These are the elements of the DB, and uh, optimal substructure and overlapping subproblem, important properties of the DP. Overlapping substructure says that if the solution, you will get optimal if and only if the lower substructure means the subproblem will have the optimal solution. That is the property. The subproblem will have the optimal solution, then the final problem will have the optimal solution. Optimal solution means optimal never means to maximize anything. Optimal means the best, either in minimum manner or in the maximum manner. So either to maximize or to minimize, right? So today we will see the LCS. The LCS is the longest common subsequence problem. So we have to find a subsequence that is the given in the two pattern. What is the longest common subsequence? So that is the maximum one we can find. So it's a DP problem, right? And another problem is the overlapping subproblem. Why the problems are overlapping in DP approach? Because the subproblems are overlapping in nature. Uh, because the solution of the one subproblem will be used in the calculation of the another one. So that's why the optimal solution of the one is used at the another one level. In this way, we will say the subproblems are overlapping in nature. There's a recursive formula defined which will be used at each and every level of the problem again and again and again. That will be call itself recursively, and we will compute the values in the bottom-up manner, and then we will print the pattern in top-down manner because the loops are reversing. They are having the loop inside the loop inside the loop. So whenever you are printing the pattern will be printing from top to down. Whenever you are computing the value, you are computing the value in bottom-up manner. That is how this approach basically works. So let's see how the LCS will gonna work. Proceed to faster for LCS. We have already covered this topic, right? This is a today topic. That is a comparison of the two strings. The only we will gonna say the longest common subsequent. The name of the problem is LCS. It come by this name. Now, what does LCS says? LCS says that the two sequences are given to you, X and Y. X is having the character like X1, X2, so on up to XM, and Y is another that is given to you. And we have to find a common subsequence between the two sequences given to you. That will be the Z, that is Z1, Z2, so on up to CK, right? You can say Z1, Z2, so on up to ZK. Right. For example, the X is given A, B, C, D, E, F, G, and Z will be given that like A, B, D, G. Then what will be the common subsequence we can find among them, right? Now see here, given the two subsequences X and Y, the sequence Z is a common subsequence of the X and Y. Now, how does it work? Like X is given to you, Y is given to you. We need to find out the Z. That is a common subsequence among the two sequences given us, right? First, we need to find out what is the, because the approach is work on DP, it means there must be a recursive formula, right? So we need to see how the recursive formula will be worked inside this. But before that, let's construct an optimal substructure for this problem. How the optimal substructure says, what does it say? It says if X is given a subsequence from X1 to Xm and Y is given a subsequence from Yn so on up to Yn, then Z is the LCS of X and Y. Now, what does it say? If Xm is equal to Yn, then Z of K that will be equal to Xm and Yn, that will be equal to that one. If Xm and Yn both are not matching, then either the Zk is not matching with the Xm or it is not matching with the Yn. Right? Now, this is the recursive equation or the recursive formula, which we say, we have already said that in the DP, each and every problem is having the recursive formula. Now, this is the recursive formula for the LCS problem. Now, what does it says? It says in the Cij matrix, we need to compute the length of LCS. It says that if I is equal to 0 or j is equal to 0, we will gonna fill 0. It means the row first will be filled by 0, column first will be 0, that will be filled by 0. For rest of the value, what does it says? If xi is equal to yj, it means that both the characters are matching with each other. Then we will take ci minus 1, comma j minus 1. Now I is here representing the row, j is representing the column. I minus 1 means row decremented, j minus 1 means column decremented. If you are doing the row decremented, column decremented, you will reach to the diagonal position. Diagonal position plus 1. If you are doing I minus 1, j minus 1 means it's a diagonal positioning plus 1 value, right? Now, else it says if xi or yj they are not same, means either here you are having A and there you are having B. The both are not matching, the vector is not matching. Then it says check it out which is the value is maximum. Either the row value is maximum or the column decremented value is maximum. So for the row decremented, what does it says? Row is like this, right? So the row decremented means you need to go the above one, right? So it says C I minus 1 comma j is the maximum one, or C I comma j minus 1, or the column decremented value. If you are in this cell, then either the upper value is lower or the side one value is lower. It means this is the row decremented, this is the column decremented. Among the both the value, which one is the maximum one, take that one. And correspondingly, arrows will be stored in the B matrix. We are having two matrices, Cij and Bij. In the Cij, we are storing the length, that is the numeral. In Bij, we are storing the arrows corresponding to the values which are given. For xi is equal to yj, we are moving to the diagonal positioning. So we will store the diagonal arrow, and for I minus 1 comma j, it means row decremented. You are moving to the upward. So the upward arrow will be stored. And see I comma j minus 1 means column decremented value. So you are moving toward here. So that's why they are having the left side arrow, right? So these are the three arrows which you are going to use in this ci minus 1 or for bi comma j, right? Cij is having the left, bij is having the arrows, right? Now see here, this is the algorithm for the LCS. What does it says? See I comma 0 will be 0 initial. It means initial first row will be 0, first column will be 0. For rest of the value, the recursive, whatever we have studied the recursive formula, it put here. Like see ij. If xi, yj both are equal, then diagonal value plus 1. Or if otherwise, we will check the maximum. Either I minus 1 comma j is maximum or I comma j minus 1 will be maximum. Whatever is maximum, we will gonna put that value in Cij and Bij respectively. We will gonna store the values. Here it is written 1, 2, 3, but actually these are the arrows. 1 diagonal, 2 means upper arrow, 3 means left side arrow, right? Now let's see for this. The x and y are given to you. These are the pattern. For x, it is having A, B, C, B, D, A, B. For y, it is having B, D, C, A, B, A. Now, what does the student do in this stage? They are not considering the first row, first column. Don't forget, in the algo, we are having first row, first column with the zero value, right? So for xi, first 0, column 0, row 0. We have to put this. This is initial. This is important condition. Now let's track the algo. What does it say? First, we will gonna go for the xi first vector A, for the y first vector B. Does your A is equal to B? No. If they are not equal, then check it out for the row decremented, column decremented value. The column decremented value upper cell 0 and the right side also 0. If you are having both the values same, no one is maximum, then we will gonna fill the 0. We will take the any of the value, both are 0, but the priority will be given to row decremented, that is the upper arrow. In the similar manner, A is not is equal to B, so the 0 with an upper arrow. A is not is equal to C, 0 with an upper arrow. A is equal to A. Now the character matches. So the diagonal value, that is 0 plus 1, 1 with a diagonal arrow. Right? A and B both are not matching, but upper we are having 0, left side we are having 1. So we will go to 1 with the this side arrow. A, both are equal. So 1 with a diagonal arrow. In this way, we will gonna fill this matrix. In this way, we will gonna fill the matrix with the arrow. All the arrow we need to store, and then we are coming with the how to print that array, how to print that subsequence basically. For printing, we need to see how the algo will gonna work. Print LCS. Print LCS says whenever the Bij is 1, it means the diagonal arrow is here. We need to print the xi and then we have to move to the diagonal arrow, right? Otherwise, just do the row decrement or column decrement. So see here, in the last column, there is 4 with the upper arrow. Do not print xi. Print xi when you are having diagonal arrow. Move to the upward. Then it is 4 with the diagonal. Do the circle A. Then move to the diagonal positioning. 3 with the upper arrow. Do not print xi. Move to the upper row. 3 with the diagonal arrow. Just circle that B. Then go to the diagonal position. You will get 2 with the left arrow. Move to the left side. You are having 2 within diagonal. Then circle C. Then go to the diagonal position. You are having 1 with the left side. So move to the left side. Then we are having 1 with the diagonal. So circle the B because xi will be getting printed in your elbow. So print xi always. Then you are moving to the positioning where A and yi both are 0. So the algo will be terminated when you will reach to the 0. Now how the pattern will be printed? Pattern will not be printed like it will not printed in the bottom up manner. It will printed in the top down manner because whenever you are printing, you are having the loop inside the loop inside the loop inside the loop. So first the innermost loop will get to print, then it will reach to the outer, then it will reach to the outer, then to the last one. Right. So whatever the last one, it will be printing the pattern like B, then it will print C, then it will print B, then it will print A. So the outcome will be GCBA. That is the required LCS for this algo. Now it is a print LCS algo. The algo is always in the DP approach. Algo here divided into two parts. One is for calculating the CIJ, one is for printing the LCS. How the pattern will be printing. This is the pattern printing algo, right? So this way it will gonna work, and the time complexity is big of nm because the n is the length of the x pattern and y is the m is the length of y pattern. That's why it is nm, right? So quickly revise the topic that we are making the two matrices. We are not making the two matrices. We are storing the value in a single matrix, but we are having Cij and Bij concept here. In the C, we are having the length of the vector. In the B, we are having the arrow, right? We are using three arrow here, diagonal, upward, and left side. Diagonal means whenever the xi and yj are equal, we are using that. Whenever the upper value, or then we will check whether the upper value is maximum value or the side one value. If it is the upper one, it means the priority is given to the row. That means I minus 1 comma j is the maximum one. If we are moving to this side, it means I comma j minus 1 is the maximum one. Corresponding to this, we are using this arrow and we are calculating their length, and then we are calculating the longest possible series. Important problem generally asked in the exam, and it generally asked in the form of the numerical. We have to do it this way. The only problem the students generally do, they do not considering the first row, first column with the zero. We have to take care of this. Otherwise, your algo will not gonna terminate. Your print tells us if it will not gonna terminate, you will not able to print the pattern, and the pattern will gonna come in a row, right? So thank you so much. I hope the topic is clear to all of you.